Right now, as you're watching this video, there's a rock hurtling through space that we almost never saw. A mountain-sized asteroid, invisible to our telescopes, hidden in the one place we rarely look, the glare of our own sun. For years, it's been there, circling, waiting, a cosmic blind spot that could have held our destruction. We call it Scooby. And until a few months ago, we had no idea it existed. This isn't science fiction. This is 2025 SE79, a 2,300-foot wide colossus locked in one of the most extreme orbits ever recorded. If it hit Earth, entire continents would face annihilation. But here's the terrifying part. There could be more like it. Hidden, undetected, lurking in the sun's shadow. This is the story of how we found the invisible asteroid and what it means for the future of our planet. Deep in the Chilean desert, as the sun dips below the Andes, a race against time begins. Scientists have only minutes, precious moments between sunset and total darkness, to scan a region of space most telescopes never dare to explore. They're using the dark energy camera, one of the most powerful eyes humanity has ever built, pointed not at distant galaxies, but at our own cosmic backyard. The challenge is brutal. Point too early, and the sun's radiation fries your equipment. Too late, and your target sinks below the horizon with the fading light. This narrow window, this twilight zone of astronomy, is where the invisible hides. And in March 2025, they found something. A faint glimmer, moving, fast, too fast. At first it looked like an error. The object was traveling at speeds that shouldn't exist for an asteroid so close to home. Its orbit traced a path that defied conventional wisdom, looping entirely inside the orbit of Venus, closer to the Sun than any major asteroid we'd ever tracked. They nicknamed it Scooby, after the famous cartoon detective, because like Scooby-Doo stumbling onto mysteries, this asteroid revealed itself almost by accident. But there was nothing cartoon-like about what the data showed. This was a planetary defense nightmare made real, a massive near-Earth object hiding in the sun's glare, invisible to our early warning systems. The discovery triggered an immediate response. Telescopes around the world turned toward the coordinates, racing to capture follow-up observations before Scooby vanished again into the solar brilliance. Every data point mattered. Every measurement refined our understanding of this phantom that had been orbiting in secret, possibly for millions of years. 2025 SE79 belongs to an extremely rare class of asteroids called Atira-class. While most asteroids orbit in the main belt between Mars and Jupiter, Atira-class dance with death in the inner solar system. Their entire orbits stay inside Earth's path around the Sun, making them the phantom menace of near-Earth objects. Out of over 1 million known asteroids, fewer than 30 are confirmed Atira-class. That's a discovery rate of 0.03%. These rocks spend their existence in regions flooded with solar radiation, hidden by the overwhelming brightness of our star. They're the cosmic equivalent of hiding a needle in a supernova. Think about that for a moment. We've mapped distant galaxies, billions of light years away. We've photographed black holes at the center of other galaxies. We've detected planets orbiting stars, hundreds of light years from Earth. Yet here, in our own solar system, less than 100 million miles away, massive objects remain completely hidden from view. But Scooby isn't just rare, it's extreme. This asteroid completes one full lap around the Sun every 128 days. Let me put that in perspective. Earth takes 365 days. Mercury, the Sun's closest planet, takes 88 days. Scooby orbits faster than any Atira we've ever found, screaming through space at speeds approaching 25 miles per second. At its closest approach, this rock ventures within 17 million miles of the Sun. That's closer than Mercury. At those distances, surface temperatures can exceed 800 degrees Fahrenheit, hot enough to melt lead, to vaporize water instantly, to crack solid stone. The orbital mechanics alone are staggering. Scooby experiences gravitational forces that constantly try to tear it from its path. The Sun's gravity pulls with relentless intensity. Venus's orbit creates periodic gravitational tugs. Even Earth, though farther away, exerts its influence. This asteroid threads a needle through gravitational chaos, maintaining a stable orbit in one of the most hostile environments imaginable. How does it survive? That's the mystery scientists are racing to solve. Most asteroids couldn't withstand what Scooby endures. The intense solar radiation should be breaking it apart, boiling away volatile materials, fracturing its surface through thermal stress. Yet Scooby persists, lap after scorching lap, seemingly impervious to the sun's fury. Current theories suggest this asteroid must be composed of incredibly dense, heat-resistant materials, possibly pure metallic iron or rock forged under such extreme conditions that it's become nearly indestructible. Some scientists speculate it could be the exposed core of a much larger body, stripped of its outer layers by millions of years of solar bombardment. Think of it as a cosmic anvil, hammered by the sun itself, tempered into something harder, denser, more dangerous than ordinary space rock. The surface of Scooby likely tells a story written in heat and radiation. Imagine a landscape where metal has been melted and refrozen countless times, where rock has been transformed by temperatures that would make blast furnaces seem cool, where solar wind has sandblasted the surface for eons, polishing it to a dark, reflective sheen that makes it even harder to detect. Here's where the scale of Scooby becomes sobering. At 2,300 feet across, roughly the height of two Empire State Buildings stacked on top of each other, this asteroid carries kinetic energy beyond comprehension. If an object this size struck Earth at typical asteroid velocities, we're looking at an explosion equivalent to hundreds or even thousands of nuclear weapons detonating simultaneously. The impact crater would span miles. Shock waves would level everything within a 100-mile radius. Earthquakes would ripple across continents. If it struck an ocean, mega tsunamis would devastate coastal cities on multiple continents. We're talking about an extinction-level event for regional civilizations and catastrophic consequences for the entire planet. The impact would inject billions of tons of debris into the atmosphere, blocking sunlight and triggering a global winter. Agriculture would collapse, ecosystems would fail. Human civilization as we know it would face its greatest test. This isn't Hollywood exaggeration. This is physics. This is what happens when unstoppable force meets immovable planet. Scooby's discovery exposes a critical vulnerability in our planetary defense network. We've been scanning the night sky, looking outward into the darkness, while an entire population of asteroids hides in the daylight glare. Our telescopes are designed to find objects against the black canvas of space, not the overwhelming brilliance of our sun. It's the cosmic equivalent of trying to spot a black cat in a coal mine at midnight, except the coal mine is on fire, and the fire is the sun. The problem is fundamental physics. Sunlight scatters in Earth's atmosphere, creating a dome of brightness that drowns out faint objects near the sun. Even in space, solar radiation can damage sensitive instruments pointed too close to our star. We've essentially been searching for threats with one eye closed, unable to look in the direction that poses some of the greatest danger. Experts estimate there could be dozens, possibly hundreds more Atiras we haven't detected yet, each one a potential threat, each one invisible until that rare moment when orbital mechanics and observation windows align perfectly. Some might be larger than Scooby. Some might have orbits that bring them closer to Earth. We simply don't know. Here's the crucial point that NASA and planetary defense scientists want everyone to understand. 2025 SC-79 is not currently on a collision course with Earth. Detailed orbital calculations show that for the foreseeable future, centuries in fact, Scooby will continue its scorching marathon around the Sun without crossing paths with our planet. The mathematics are clear. The trajectories don't intersect. We're safe from this particular giant, at least for now. But currently is the operative word. Asteroid orbits can change. Gravitational interactions with planets, close encounters with other objects, even the subtle pressure of sunlight itself can alter trajectories over long time scales. What's safe today might not be safe in 1,000 years or 10,000. This is why monitoring matters. This is why discovery matters. You can't protect against what you can't see. The discovery of 2025 SC-79 represents both a triumph and a warning. A triumph because it proves we can find these cosmic ghosts when we look in the right place at the right time with the right tools. A warning because it confirms what scientists have long suspected. We don't know what we don't know. New initiatives are now underway. Space-based telescopes positioned away from Earth's glare. Infrared detection systems that can spot heat signatures against the sun's brightness. International collaboration to share data during those precious twilight observation windows. NASA is developing specialized missions designed specifically to hunt for these inner solar system asteroids, to map the invisible threat landscape that exists in permanent daylight. Every asteroid we catalog is one less surprise waiting in the cosmic shadows. Every detection expands the map of our local neighborhood, making the invisible visible. Each discovery teaches us more about the complex dynamics of our solar system, about the hidden dangers that lurk in places we rarely look. Scooby may not be coming for us, but it's shown us where to look for the ones that might. It's reminded us that the universe doesn't care about our limitations, our blind spots, our technological constraints. The cosmos operates on its own terms, indifferent to whether we're watching or not. And in the infinite darkness of space, where mile-wide mountains of rock drift silently through the void, that knowledge might just be what saves us. The hunt for hidden asteroids continues. The Twilight Watchers remain vigilant. Because somewhere out there, in the blinding light of our sun, the next discovery is waiting. We just have to find it before it finds us.